Hello everyone, this is Abhijit Dasgupta from 366 PyTech and welcome to another session of FLO Blockchain App Development by SkyPiCast. We will be having these live online sessions till 15th of September 2018 every Tuesday, Thursday and Saturdays at 9 p.m. IST. So don't forget to tune into all of those to continue in this journey of apps development on FLO Blockchain with us. We would like to thank Ranchi Mall for their continued support in our blockchain journey. We would also like to thank the entire FLO community and its dev team specially for all the support. In this session, we will discuss about the FLO C SDK that we at 366Pi have developed to help C developers create dApps or distributed apps on FLO blockchain easily. This SDK contains a connector library which implements the JSON RPC commands of FLO, which we discussed in our last session, as a DLL or dynamic link library with exception handling as per the blockchain standards. This SDK is an open source project and is available in GitHub. The GitHub link will be available in description of this video. We are continuously in the process of updating the SDK and trying to add and update new RPC methods as they are implemented in FLO, as well as make it more developer friendly. Starting from today, our sessions will be more code specific and less theoretical, so as to say. So let's start. Let's do a quick recap of what we discussed in our previous session. In our previous session, we discussed how to set up the FLO wallet on Windows operating system as well as on the Ubuntu operating system. We did have a look at how the FLO configuration file or the FLO.conf file is set up, what are its different parameters and what they are supposed to do. We also saw how to make RPC calls using the debug console of the FLO core wallet as well as using the FLO CLI utility. We also did have a look at sending and receiving FLO into the FLO core wallet using some testnet data. So I hope that was clear, but if you do have any questions, do reach out to us. So moving on to today's area of discussion, we would be talking about the FLO C SDK or the software development kit. We will be discussing why the need for the C FLO SDK, what are the requirements for our FLO C SDK. We will discuss about the GitHub repository for this SDK as well as how to clone it and import it into your computer and work around it. We will also have a walkthrough of the entire SDK project in terms of the SDK project structure, what are its different components, how is it all working together, and so on a small demo of how the SDK is working. So that is something that we plan on doing today. So starting with the first topic of our discussion today, why the need for the FLO C SDK. Let me tell you, we at 366Pi are mostly engaged in projects which are on Microsoft platform. So it was very obvious for us to select C# as the platform of choice because of the platforms that we were currently working, which were on Microsoft, and C# works well with that. We saw that the FLO C SDK was something that would help C# developers trying to develop distributed apps or dApps on FLO. C# as a language has an awesome support from Microsoft as well as the community of C# developers. You can find a lot of help and information all over the internet for C# as a language. It is an awesome language which is pretty much similar to other languages like Java in terms of its syntax, its coding styles and everything. and it is pretty easy to learn when you come to it. This particular SDK written in C# will help you to develop dApps very easily and quickly without worrying about the connectivity and all the communication with the FLO blockchain directly. Our SDK will handle all that in itself. The SDK library can be implemented in any type of Microsoft application, be it a console application, a desktop application, a web app, or any APIs. We ourselves have used this SDK to build some of the apps which we will be discussing in later sessions that we do. C# as a language is very similar, just as I told you, like Java in its coding style, as well as the syntaxes in some ways. So that is the reasons, these are some of the reasons why we chose C# while developing this SDK. What we also do want to tell you is that it is not a requirement that anyone should work only on C#. Once you get to know about the FLO blockchain, its RPC commands, and how our C# SDK works, you are very much free to develop your own SDK for the language of your choice, be it for Java, Python, anything. That is most welcome, and that would help the community a lot. Let's just have a look at what are the requirements that you need in a computer for developing apps over the C# SDK. For developing apps using the C# SDK of FLO, the basic requirements that you would require on your computer are a Windows operating system based computer, obviously because it's a Microsoft based platform that we are working on. You would be requiring .NET Framework 4.6.1. I have attached the URL for downloading the .NET Framework from Microsoft.com website in this presentation. I will also make sure to add these links in the description of this video. For working on this particular project or creating your own projects using the SDK, you will need some sort of an IDE or integrated development environment for your development purposes. We would suggest you use Visual Studio. The URL that is mentioned on this particular slide will take you to a download section wherein you can download the Visual Studio flavor of your choice. If you do not want to spend any money on your IDE, you can definitely use the community edition that works very well. You also need the FLO wallet installed, synced, and running on your computer where this particular application is going to run. Obviously, if you are going to create an API, the API needs to communicate directly with the FLO wallet using the RPC, FLO RPC allowed IPs or the credentials that have been synced. We discussed that in our previous session when we talked about setting up the wallet and setting up the configuration of the FLO.conf file. It would be an added advantage if you have knowledge of C# and you are hands-on with working on Visual Studio as an IDE for working on this project. But if you don't have any knowledge of C# and Visual Studio, it's not a big deal. It's not very easy. It's not very difficult to learn, and you can just follow along with us, and you can pretty much work on the applications that we do. Let's just move ahead and see what the entire FLO C# SDK architecture is like. In this particular slide, what we are going to show you is how we have envisioned our SDK to design with. If you see in this particular diagram, we can have desktop applications, web application, web APIs, or any type of applications that will implement our SDK internally in the applications. The users will directly interact with the desktop web or web API applications either directly or through the internet. The applications in themselves will be implementing our SDK dynamic live link library. The FLO C# SDK in itself is divided into some components. Those components being the RPC methods component, wherein all the RPC commands of the FLO wallet are implemented. We do have some request response data models which handle all the requests and responses that the Flow wallet returns. Just to handle any type of exceptions that is caused due to some erroneous request or due to any connection issues or any type of exceptions, we have also created some exception classes based on the exceptions that can occur on a blockchain, especially Flow blockchain. The RPC method component in the FLO C SDK, when receives any type of request from the desktop or the applications implementing the SDK, will receive the request and send the request to the RPC connector. This RPC connector is something that directly interacts with the Flow wallet or the Flow node that is running on your computer or on a whitelisted server. The RPC connector in turn makes HTTP RPC calls to the Flow node and submits all the requests to it. The Flow node processes all the data, performs the transactions, and returns the data back to the RPC connector, which in turn gives the data back to the RPC methods component, and the RPC method component converts the data to a JSON value, and it is returned back to the application implementing the SDK. The application that is implementing the SDK then parses that particular JSON into a readable format and performs the logic as per the application's logic itself. So this is something that the architecture of the entire FLO SDK is all about, and this is something that we are working on as the SDK part of it. So let's just move ahead with our presentation. The next part of this session deals with the SDK repository that is available as an open source platform on GitHub. So if you want to download and work on the SDK repository by adding something or forking the entire repository and working on your own, you can download the repository from github.com using the URL that has been mentioned. We will also make sure to add this link in the description. You can clone or download the entire repository to the development environment that you are going to use. Once you have downloaded the repository to your computer, you will find out that in the directory of that SDK repository, there is a .sln file available. This SLN file is called a solution file, which the Visual Studio IDE uses to manage all projects inside of it. Once you open this SLN file using the Visual Studio that you have installed, you will see that there are two projects as part of this SLN file or the repository. One being the FLO SDK project, which is the main library project or the actual DLL project, which once built will create the DLL file which can be used in any application, be it a Visual Basic or a C# application, where the FLO blockchain is to be integrated. For this demo purpose or as part of this repository, we have also added a sample FLO SDK test project, which actually implements this particular FLO SDK library project and is used to test the library functionalities. We will have a look at that when we look at the project itself. So let's move ahead and see the SDK project in action and in Visual Studio and go through the structure, its components, and different features. Just give me a moment to stop this presentation and move to the Visual Studio project. As I said, this is the repository on GitHub which you need to go to for downloading this entire blockchain SDK. As you can see, this is renamed as a FLO C SDK. The current version that we are maintaining is the 1.0.0.0 and the requirements of 4.6.1 .NET framework, as well as an external reference that has been used to handle all JSON data request and response is a Newtonsoft .json package that we have used. The URL for downloading that particular package has also been mentioned in the GitHub repository. We have also mentioned some descriptions about this particular wallet and what it can and what it cannot do. We have also mentioned what the repository in itself contains. Just as I said, it contains two projects, the FLO SDK as well as the FLO SDK test. This entire description or the README contains how to use, how to download and sync the FLO blockchain, configure the conf file, as well as how to build the projects, how to add the SDK DLL, and the entire process of using this particular project in your application. So you can just go to this particular GitHub repository and have a look at it. Once you want to download and use it as on your development computer, you just need to go to this particular green window button and click on download zip if you want to download it as a zip and use it. Otherwise, you can just copy this entire GitHub repository URL and can check out your data into the GitHub client using the GitHub client of your preference. So once you have downloaded that, you will be having a project folder with this entire structure. In this FLO SDK folder that you download, you will see that you will have this FLO SDK.sln file, which I was talking about in my previous slide. This is the solution file, which once you download into your computer and open with Visual Studio, will start the project in this Visual Studio IDE environment. The Visual Studio that I am using currently is Visual Studio Enterprise version 2017, and this is a theme which I am using as a dark theme. You may have a lighter theme and the look may be a little different as per the version that you have downloaded. But any which ways, once you download the entire FLO SDK project into your computer and open the SLN file, you should have this particular section available with the Solution Explorer. In the Solution Explorer, if you see, we have two projects over here. One is the FLO SDK project and the other one being the FLO SDK test project. These two projects have been set up as the FLO SDK project has been set up as a library project, while the SDK test project has been set up as a console application project. Just to show you how these projects have been set up, we will just click on one of those, for example, the FLO SDK library project, and we will go to the project menu in Visual Studio and click on the bottommost link saying the FLO SDK properties. Once we click on it, it will show the entire application properties with the assembly name, the output type. This is where we set up a project's output type, whether that project is needed to be built as a library function or as some other application like console or a Windows application. Since this is a library application, we have set up the output type as a class library. What you can also see is we have set up the target framework for this particular project as .NET 4.6.1 as was mentioned in our requirements. We will just close this particular properties windows and move ahead with the next part. Let's just start with the FLO SDK project and its components. When we expand this FLO SDK project, you will see the structure that is available for this project. In this, the bin folder is the binary folder that gets created when you build a project. Visual Studio creates this itself. Once we create and build this particular application, I will show you that this entire project gets compiled into a dynamic link library or a DLL file that can then be implemented into any application of our choice. The next component or the next folder that you currently see is the connector folder. What we have done is we have organized our project into different directories containing different components of our SDK. The FLO connector directory, which contains the FLO rpc.cs or the C# file, is the most important part of this SDK. Once we open this, you can see that there is a bunch of C# code that is written. This particular piece of code, what it does is it actually communicates with the FLO wallet that is currently running on your computer. The FLO wallet that is currently running on your computer or on a server from where the application's computer's IP is whitelisted, you can make these RPC commands using this particular connector RPC utility. So this particular class file that has been created will actually communicate directly with the FLO wallet. So this is something that we will be discussing later. The next folder that you are going to see here is the error codes. Every blockchain has some error codes that can happen or that the blockchain actually returns when those errors occur during any RPC calls. So if you see, we have created a list of some enumerables or enums with the RPC error codes that are mentioned. If you're thinking where we get these RPC error codes, it is very easy. Since FLO is a fork of the Bitcoin cryptocurrency, you can just find out the error codes that Bitcoin has, and those are pretty much the same for FLO as well. This is the English Bitcoin wiki page that I am currently showing you on screen, and this contains all the Bitcoin client API calls or the RPC calls that are available. Obviously, the latest version has some extra RPC calls that are available, but the main area of interest that we have in this page is this particular link which says error codes. Once you click on it, you will get to this particular section which says the RPC protocol.h file should show all the list of error codes and their meanings. Once you click on it, you will be forwarded to the GitHub link or the GitHub repository of Bitcoin, and it shows you all the different error codes that are available in Bitcoin's latest version. So these are pretty much the same for FLO blockchain also. So we have reused this particular error codes into our application for handling all the error codes. So let's go back to the project. So this particular error code class only mentions all the error codes that are available. The next folder that you can currently see here is the exception classes. These all classes that are mentioned over here deal with different types of exceptions which are handled by these error codes, and these classes actually handle all the exceptions that the FLO blockchain returns. So any transaction that we do through this SDK onto the FLO wallet or the FLO node, if there is any type of exception, be it a request timeout or a connection error to the FLO wallet, if the FLO wallet is not running when you are doing those transactions, or if there is some issue with the deserialization or serialization of the data that is going to the FLO wallet and coming from the FLO wallet. If there are any server exceptions which are available, any type of exceptions that are available or that occur in that particular FLO transaction, these particular classes handle all those. So this is a set of classes that we have created for handling all the different types of error codes. The JSON RPC error class that you are currently seeing here has two properties. One is the code and one is the message. The code actually returns the RPC error codes that we saw, and the message returns the actual error message that that particular error code has returned. So this is something that is related to the exceptions handled by the SDK. So as a developer using this particular FLO SDK in your applications, you need not worry about all these error codes and exceptions. What you just need to know is you are pretty much well set when you use this SDK that all the error handling will be done by the SDK itself. You just need to put your code in a try-catch block with the proper exception classes inbuilt. We will see that in our next few minutes. The next directory that you are seeing here is the RPC methods. If you remember, in our last session that we talked about, we saw that there are hundreds of RPC commands that are available in a FLO wallet. What we have done is, in this particular SDK, is that we have created all those hundreds of RPC commands into C# methods. So this particular class file that you are seeing, the IRPC method, is the interface for all those methods that have been declared in our SDK. So these have been categorized and organized as per the different utilities or different categories of the RPC calls that they belong to. And the actual RPC methods implementation has been done in this particular RPC methods.cs file. So whichever methods interfaces are available in this, for example, the string getInfo, its implementation is available in this particular file. So if you see, once we have come to this particular RPC method folder, every RPC method folder, what it does is it actually creates an object of the FLO RPC class, which is our FLO connector RPC class. So this connector RPC object, once created, it requires the username and password of the RPC user and password credential that is set up in the flo.conf file, along with the wallet URL, which is actually the IP address, or if you are running the wallet on the same PC, it will be localhost. Also, if you remember, we talked about a port that requires to be opened, which was 7313 when we last saw it in our last session, for the RPC communications to happen through the FLO wallet. So these values, the username, the password, the wallet port, are all set up in the flo.conf file of the wallet that you have set up. The wallet URL is the IP address or the local host which needs to be passed on. We will see how this is done in a direct application. Once this object is created, we have named it a con object. We just need to make a make request method call and call the function or the get or the actual RPC method name. Once this method name is passed, if any values or if any parameters are also needed to be sent, they can be sent as values to this, and this particular function will call the FLO wallet directly, make the RPC calls with the RPC method name that is provided here, and if any data is required, that data is passed on here, and that communication goes to the FLO wallet. The FLO wallet performs those transactions and returns the values which is stored in this REST value. This REST value is then returned back to our application that we are creating, and then the parsing of that response is handled at the application level end. So let's not get into the details too much and make this session very boring. And let's just look at the last folder that we have created here. This is a JSON RPC request and response model class that we have created. For some of the applications or some of the methods that are required, some parameters or RPC parameters needed to be in form of classes that needed to be passed on. So we have created these model classes as JSON RPC request and responses to handle all those values in form of objects and rather than as string values. So this is something just to organize the request and response into objects and have more flexibility into accessing those values rather than parsing strings. So these are request response classes are created for that purpose. So once you have this particular project ready in your Visual Studio, what you can do is you can just build this application, and what Visual Studio will do is it will actually compile this entire project. So what it will do is, once if we just right click on this particular project and click the build option, what you will see is you will see a message saying build 0 succeeded, 0 failed, 1 up to date. You're seeing this message over here in my computer because I have already built this particular application once and it has just updated that. If you're building this for the first time, you will either see 1 succeeded or 1 failed. If it shows 1 failed, it means something bad has happened and your library has not synced or has not compiled. And if it shows that it has succeeded, that means you are good to go. So let's just move ahead and see what the build option actually does. So if we just go to if I just open this particular project folder, the entire project folder, this is the project folder that you will be getting once you download the GitHub repository. What will happen is once you build it, you will get to this FLO SDK folder, go to the bin folder, and in that bin folder, you will have this folder called debug. In that debug folder, you will see that you will have this FLO SDK.dll file. This is the actual output or the outcome of our build operation that we did on Visual Studio. This is the actual SDK DLL that needs to be used in any application of your choice for implementing this entire SDK and the connectors. This is the only file that is needed. And addition to that, you will need the newtonsoft.json DLL for handling all the JSON requests and response into as form of objects. So this is the only value that you need to create. So if you don't want to set up the entire SDK into your computer and don't want to create or build the SDK DLL from scratch again, you can just download the repository and go to this DLL file, copy this and use it into your application. That will work very fine. So let's just move ahead and see the next project that is available as part of this SDK. The next application that is available as part of this SDK is the FLO SDK test. This is actually not the SDK DLL. This is actually a sample application that has been created to showcase the functionalities of the SDK. What we have done here is we have created a simple console application, which actually makes a few RPC commands through the SDK to the FLO wallet running on our computer. For this purpose, what we are going to do is we will be seeing that in the app.config file, we have to mention some of the values for the app settings. In this, what we have done is we have used the username password. These will be the FLO.conf RPC username and RPC password that you have set up in your FLO.conf file. This is the wallet port that the port is running, or the RPC server of the wallet port is running, and also the wallet URL. This is usually http://localhost if the wallet and the application that you are running on the same computer. If the wallet is running on some other computer on a network and you are accessing that from an application which is not on that computer but on a different computer, you need to mention the IP address of the computer on where the wallet is running. But obviously, in that case, you will have to whitelist the IP of the computer where this particular application is running in the FLO.conf file as RPC allow IP parameters, so that any request made from this computer will be accepted and processed by the FLO wallet. So this is just a test credential that I have used for this particular session, and I'll just show you how this particular product or this project is calling those FLO RPC commands using the SDK. The next thing that I want to show you is in the references section in a typical Visual Studio project that we do. The references section is the section wherein you refer all the external libraries that you want to use, external or internal Microsoft libraries or external libraries. So what we have done here is, if you see this, we have referred the FLO SDK DLL into our application. So this particular application or console application is actually referencing this dynamic link library which we just created over here in this previous project, and that entire library is being referenced here. So we do not need the entire project available. This is just for the demo purposes. In the applications that you create, what you need to do is you just need to add your DLL by clicking on the references section, clicking on add reference, and once you have a dialog box with add reference, what you need to do is you just need to go to browse and select the FLO SDK.dll file wherever it is available on your computer after compiling, or if you have downloaded that from our GitHub repository. So what you need to do is you just need to select that particular SDK.dll file and it should be good to go. So what we'll do is we'll just click on it once you have browsed it and you just click on OK. Once you click on OK, you should be seeing that available here. And once that is available here, the entire FLO SDK features and features available which we were just seeing is entirely available now on your project also to use. Once that is done and the app config is set up, what we'll be seeing next is the program.cs file. This is, we have done here for demo purpose, a small console application, which will just call up some values from the FLO blockchain and perform some basic transactions. So in the main program that we have created, we are actually initializing the username, password, the wallet URL, and the wallet port from the configuration app settings that we created on this app config. So what we are doing here is we are retrieving those values from our config file and storing them into some variables of our choice. Once that is done, what we are going to do is in the FLO SDK, there is a class called RPC methods, which we saw here in methods. What we need to do is we need to create an object of that RPC method and call the constructor of that particular RPC method using the username, password, the wallet URL, and the wallet code. Once that constructor is called, the object for RPC methods is created and it is ready to make communications with the FLO wallet that is running and connected through the parameters that we have just passed over here. Once that is created, this particular RPC method object can be used to call all the methods that were described in this particular RPC methods class. So all these RPC methods that we have implemented, they are all available to be accessed from this particular object. So if we see, to make a very basic RPC call using this SDK, what we need is pretty much these 4-5 lines of code. This is the only thing that is required now once we have the SDK in place. Also, just to keep things into perspective and keeping the data in the, and handling the exceptions, what we have done is we have enclosed this data into this piece of code into the try catch block. So this particular try catch block is actually implementing our custom RPC internal server exception classes, and the exception object that is passed, it will retrieve the code and the actual message. So these exception codes and exception messages that the SDK passed can then be used in any which ways as your application is required to do. So what we do here is, once we receive these exceptions, we are actually displaying them to the user so that the user can just have a look at those for this demonstration purposes. For production applications, you can handle these exceptions and perform the logic as per the exceptions received if there are any. So we'll just have a look at how these applications are working by just few lines of code by calling the RPC methods using the SDK. So what I have done here is, in this repository, I have called a few of the RPC commands using this repository. For the first demo that I'm going to show here is, I'll just call in the get info RPC and I'll just comment out all the lines. So in C# Visual Studio, what you need to do is, if you want to comment a piece of code, you just select on it, and in the topmost part of this taskbar, what you see here is these green lines. You just click on comment out and they should be commented out. You just save it and you can just run it. So if we just look at this 4-5 lines of code, what it is doing is, it is actually using the RPC object that we created and is calling the method called getInfo. The getInfo method in RPC of FLO wallet, what it does is, it actually retrieves the information or the blockchain and the wallet information from your wallet that is running on your computer, and it returns the information in form of a JSON value. What we are doing here is, we are calling the rpc.getInfo function, and the value that it will return as a string value. It is a stringified JSON value. Just to have some value in form of objects and having ease of usability, what we are doing here is, we are parsing this entire response value into JSON objects using the Newtons of JSON package. So the Newtons of JSON package has a gObject.parse method, which receives a string value and converts it into an object as per the response or the JSON that has been passed to it. So once that is retrieved, the object may have a value called or a parameter called error. If this particular error parameter is available in the object that has been returned by the FLO wallet as part of this SDK response, it means that the particular RPC command that we run has some errors. So what we are doing here is we are checking whether object error parameter converted to string is null or empty, which means if the object's error parameter doesn't contain anything, it means that our response is error free. So we do show the entire result of that particular RPC command using the object result parameter, and we should see the response that the FLO wallet gave. But if this particular error value is not null or empty, it means that the response has some errors. In that case, if we just want to show the error that has come from the wallet, we can just show the object error parameter in the using the error index of the object array. So this is something that can happen. So these 4-5 lines of code can just get you hooked up to the FLO wallet. So just make sure that your FLO wallet is up and running and the flow.conf file is set up, and all those informations are available in the app.config. So let's just run this application and see what happens. So to run this particular application, we will just click on the start button, and it should start up a command prompt sort of a window, which is a console application's default output, and it should start with something like this. And once it makes the connection, see, this is the get info RPC commands output that is retrieved by the RPC command also, and this is something that we are getting through our SDK. So this is a very easy and 4 line of codes. Using 4 lines of code, we are getting these RPC command outputs into our C# application. Let's just go ahead and do some other calls also. So let's just comment this piece of code and uncomment another command that we are going to see, that is the get help. If you remember, in our last session that we discussed, we were having a look at this particular FLO core wallet, and in there we saw the help and debug window. In here, what I showed you is there is a part called the debug console. The debug console actually lets you run RPC commands directly. In here, I told you that if you just type in help and press enter, you should see a list of all the RPC commands that the FLO wallet has. And if you want to see a particular help details for a particular command, say for example, help for get balance RPC command, you can just do that by clicking, typing help space get balance or the RPC command. And what it will do is it will show you the entire help document for that particular command itself. So what we are mimicking here is we are mimicking that exact help command using the FLO C# SDK that we have created. So this is something that is pretty much same. So what we'll do here is we will just call in the help command and we'll just run. So what you actually need to do is, the rpc.help method is the help method, and what you need to pass here as parameter is whichever method or whichever RPC command you need to see the help for. So I am going to see the help function or the help details for get balance. So what I need to write is rpc.help, which is the implementation of the help RPC command, and what I'm passing as a parameter is a string, which is the get balance RPC command. I want to see the help for get balance. So what it should do is it should retrieve this exact detail that we were seeing over here and show it in our console. So let's just run it and see what happens. See, this is the exact output that we were getting on our FLO debug console, and this is something that we are fetching right now using the C# SDK into directly our C# application. So this is something that you can do in your application and perform any type of RPC commands directly using the C# project that you are working on. So this is just a glimpse of what we can do using this particular SDK. Just for this demo purpose, let's just do one last transaction using this particular SDK, that is the send transaction. If you remember, what we did in our last session was, we sent some flow from this particular wallet to some address. what we are going to do is we are going to perform that same exact transactions using the C# code that we have created here. So for that particular transaction to happen, what we need to do is we need to implement the send to address RPC method that we are doing here using the SDK. The send to address RPC method actually requires a few parameters that you can see here on the screen. The parameters that it requires are in this order. It needs the recipient's flow address. It requires the amount to be transacted in decimal format. It requires the comment and comment to values in string format, which are just for keeping the comments in the wallet. What it also requires is a Boolean value, which is either a true or false for a value called subtract fee from amount. If you remember, when we talked about transactions and flow transactions, whenever we transact any amount of tokens from a wallet in cryptocurrency, there is a transaction fee attached to it. This particular parameter, if you set to false, what it will do is, say for example, if you are transacting 10 flow and it requires 0.1 flow for a transaction fee, what it will do is, if you set this particular subtract fee from amount parameter to true, is it will deduct that 0.1 flow token of transaction fee from the amount that is being transacted. So the amount of 10 flow that was being sent will get deducted to 9.9 flow, and that 0.1 flow will be deducted as transaction fee and be distributed as the block reward or the transaction reward to the miners. If you set this particular value as false, the transaction amount that your wallet will expend is 10 flow for what is actually sent to the receiver plus 0.1 flow as transaction fee. So the entire cost that you incur is 10.1 flow if the amount is not subtracted or the fee is not subtracted from
Hey guys, looks like either Abhijit is offline or I am offline. Yeah, let's wait for Abhijit to be back in a moment. Sorry about this.
I really apologize for this, friends. Just had some technical difficulties. I'll just resume the presentation from where we left. So what we were discussing about was using the C# SDK to send transactions to the FLO blockchain. So what we were discussing about was the subtract fee from amount. So the subtract fee from amount, actually what it does is, if set, it subtracts the transaction fee directly from the amount being transacted, and if it's set to false, it actually adds that transaction fee to your entire flow expenditure that you are doing. Another thing that it requires this particular send to address is replaceable value. So what the replaceable value does is, it actually, if set to true, it means that your transaction may be replaced by another transaction with a higher priority when it goes to the blockchain and is being mined. If the value is set to false, it means that your particular transaction can never be replaced by some other transaction with a higher priority. The next value that requires to be set is in form of integer value, that is the conf target. It means the confirmations, that minimum number of confirmations that is required for this particular transaction to be accepted as a confirmed transaction. Then the estimate mode, which is usually set to unset, and then the flow data value, which is passed as a string value. So what we have done here is we have set up this particular send to address with all the parameters. If you see here is we are sending 1.0 flow back to the flow address that we are sending here. A test address has been used here, and what we are doing here is we are sending 1.0 flow. In C#, when you define a value as a decimal value, you add a capital or a small m after that particular value to be for this to show that this particular value is a decimal value. So what we are going to do here is we are just going to run this particular application and see that this one flow will be transacted to the address that we have just mentioned here. So let's just run this application and see what happens. So if you see the transaction that we did, the transaction actually sent one flow back to the FLO blockchain, and this is the transaction ID that we got. So let's just copy this and see whether this particular transaction actually made its way to the blockchain using the blockchain explorer, if we can see. So what we are going to do here is we are going to the flow site or the flowchain.in testnet blockchain explorer, and what we will do here is we will just copy our transaction ID that we just got from our console application, paste it and hit the enter button. So what it should show here is the entire transaction details. So if you see here, we have transacted one flow, and this is the transaction fee that was also expended from our wallet. This is the message that was sent as part of the flow data, and still it has not been confirmed, so it is showing as an unconfirmed transaction. So if we see that we just by writing 4 or 5 lines of code, what we have done here is we have implemented the flow RPC commands, or we have created a small distributed application or a dApp using C# language and FLO blockchain. So this SDK actually makes your life very easy, and we have created APIs, applications, web applications in our organization using this particular SDK as the backbone, and have created applications very easily using this. We are in process of continuously updating this particular SDK and making it more developer friendly and making it feature rich in the future also. So let's just conclude this session of ours for today, and I hope it was an informative and helpful session for you. And as always, we would be happy to receive any suggestions, feedback, or questions regarding the sessions and topics in your email, in our email ID, which is mentioned on the screen, abhijit@366pitech.com. And we usually do revert back in a day or two with your answers. We would also request you to subscribe to our YouTube channel and join the Telegram group, and also follow us on the social media. We are available on Twitter, Facebook, and LinkedIn. The links were sent on this session's email, and we will also make sure to add them in the Facebook on the YouTube description of this particular video. And also please spread the word about SkyPiCast and the sessions so that we can reach more of you in the future. So thanks and goodbye, and see you in the next session.